Let's take another look at a four-input KMap. This time we're going to be given the function in a little bit more of a succinct form, and that is the shorthand sum of products notation. So remember that this is saying what our output is, x. This sigma is indicating that's the sum of products. And then A, B, C, D is indicating what our variables are. And then in the shorthand notation, each one of these numbers in this list is indicating which row in the truth table is a 1. Or in the context of our KMap, this is actually indicating which cell is a 1. So let's just find those cells and mark them as 1s. So 0 is a 1, 2 is a 1, 5 is a 1, 7 is a 1, 8's a 1, 10's a 1, 13 is a 1, and 15 is a 1. So this is what our KMap looks like. And of course, we know that our sum of products form is a valid function, or it's a valid way to display this expression, but we know that our KMap can actually be used to simplify things. So let's now see if we can find our implicants. So we should see this guy is like the big juicy one that we're waiting to circle, right? We know that we could circle this guy, but we can hopefully at some point we should be able to see that we can go right to this group of 4. And then we've got these straggler corners here, right? We've got this corner, this corner, this corner, and this corner. And you might first be inclined to say, all right, we've got some small groups there. We've got 4 small groups, in fact. But don't forget that these edges meet one another. And so then you might say, oh, well, we can do something like this, right? We can do that. Well, also don't forget that these corners, all the corners also touch. So if all the corners touch, that means that all 4 of these can be covered by the same implicant. And that's how we draw that, right? When all 4 corners touch and they're all have 1s, we can get an implicant that way. And now let's look at our distinguished 1 cells. Turns out they're all distinguished 1 cells because there's no overlap in this specific one, this specific cover. So since there's no overlap, and there's distinguished 1 cells in each one of these implicants, that means they're all central prime implicants. And so that means our cover should be fully minimized. So let's look at this middle guy first here and figure out what its simplified term is. So we've got A goes from a 0 to a 1, so it changes. But B stays as a constant 1. So we know we've got a B here. And C changes from a 0 to a 1. D stays constant, so we can factor that out. Alright. Now this one's a little bit tricky, but it's still the same idea to do these 4 corners. So first let's see what's changing in these 2 columns here. So it looks like A is changing, B is staying the same, and it's staying as a 0. So that means we have B prime. Looks like C changes, and D stays the same, and it's staying as a 0. So that means our final function is x equals BD or B not D not. So there we go. That's our simplified function.